Hello, welcome to the video notes for lesson 9-2, exponential functions, day 2. This begins on page 7 in your notes packet. The learning targets for this lesson. I can evaluate an exponential function, and I can solve real-world problems. And that's really the big part of this, is the real-world problems. And we have an example of that right below. Well, it's an imaginary real-world problem, if you will. Which would you rather have? Would you rather work 7 days at $20 per day, or be paid $2 for the first day and have your salary double every day for a week? Now, some people are saying, well, that's obvious, I'd rather $20 per day. But if you look at the table below, you'll notice that the total that you get at the end is pretty different. And I think a lot of people get surprised at how quickly, when you double something, how quickly it can get larger. By the way, I realize the title for this column is a little bit off. It says $2 doubled each, it should say day, per week. But anyways, so the total comes from adding all these together. Now, that's a little different than what you earn each day. So let me move this down so we can start answering some questions. So it's write an equation for each model. Now, to do that, I am going to write a let statement. And the let statement, so the variables we're going to use are the same for both. So we're going to let y equal the amount of money for that day. For that day. And that's really important because, and I know that's not great English, but on each of these days, you are going to be getting a certain amount. For the one option, it's the same amount each day. But for the other, it's obviously changing. So what is x going to be? X is actually not even part of this first one. It's actually part of the second. X is the number of the day. The day number. Alright, so an equation for this first one is just simply y equals 20. It doesn't matter the number of the day, because no matter what the day number, you get $20. On day 7, you get $20. On day 100, you get $20. On day 1, you get $20. But for the other one, it's doubling every time. And what this looks like is one of our exponential functions. Y equals 2 to the x. So whatever the day number is, that is our exponent, and that's how you end up with these numbers. Alright, so using the exponential model, this number here, or this equation here, how much would you have on day 14? So, since the number is 14, we're going to plug that into our equation and find out what we get. And the number is actually pretty significant. On day 14, you get $16,384. Wouldn't that be wonderful? Now, that is not the total that you have, because you'd have to add up all the numbers above that. That's just the amount that you get for that day. On day 14, for the other example, you would just get $20. That just stays the same. How long would it take to earn $1 million in one day? So this is going to be one I want you to try on your own. See if you can figure out what day number. Obviously, it's going to be more than 14 days, so see if you can figure out the pattern and come up with a way to figure out when you break or when you go over. So let's add to this, at least $1 million, because you're not going to hit it exactly. I want you to answer it on your own, and while you do that, let's take a look at the next page. So the next page, we're going to get some more experience with writing our exponential functions. And this is just the first exposure that you have to it. In the previous lesson on day 4, there is a table or something that shows you actually let me go back to it, what the exponential equation looks like. And here it is. This is page 4. It defines an exponential function and it shows you what it's supposed to look like. Y equals a times b to the x. Now it says a is a non-zero constant. There's something else I want you to add to that. A is the initial value. And if you're not sure what initial value is, basically it's the amount of money that you start with. Alright, so now I'm going to clear the screen and go back to page 8. Your science class is collecting cans. You start with 150 cans. Your collection triples every week. How many cans will you have collected after 7 weeks, after 15 weeks? First, let's fill in the table. So the initial value is 150 cans. The pattern, well, there is no pattern yet. After 1 week, it triples. Right? It tells us that it triples every week. So triple 150 and you get 450. What's the pattern? We're multiplying by 3. Then, to get to the next one, we are tripling again and we get 1350. And how did we get that? Well, we multiplied by 3. And keep on going. Now, another way to do that, multiply by 3, and you probably are thinking about this from the previous page. So let me continue. 4,050 multiplied by 3. 12,151, that's a lot of cans, multiplied by 3. 36,450, and you get the point. So, I bet some of you are saying, oh, well that's y equals 3 to the x. Now notice I left a little space here. Yes, because we are tripling, your base is 3, and x is going to stand for the number of weeks. So let's write our let statement. Let y equal the total of cans, and let x equal the week number. I almost spelled week wrong. Alright, so the problem is, in this equation we haven't factored in this as starting amount. Well, going back to what I just explained from page 4, that A, the part that comes in front, is the initial amount, so 150 times whatever you have here. Now, what's nice about this is you can use this to figure out any number of weeks. So let's take our workspace and split it in half. So week 7, if I plug that into my equation, 150, I should have let you probably figure this out on your own. 3 to the x. Oh, sorry, not 3 to the x, 3 to the 7. That's the week number. And when you plug that into your calculator, you get a nice big number. 328,050. And don't forget your label, cans. So, for week 15, oh boy, this is going to be a monster. Y equals 150 times 3 to the 15th power. So, when you plug that into your calculator, you get an enormous number, 2152, if your calculator is big enough, 336, 050. Now let's go back through the number and put a comma every 3 digits. And it looks like we got 2,152,336,050 cans. I don't know if we could fit that many. Alright, so that's how you solve these types of problems. Now, technically, we are just learning about these equations, so some of you might just continue these tables on, or continue to multiply by 3, and that's fine, but you're going to see that it's going to take a long time, so the sooner you can understand how to write these equations, the better. Now, there's more problems to do. There's this problem here, a population of 2,500 doubles in size every 5 years. What will the population be in 30 years? See if you can figure this out. At least try to find the number, even if you can't do the equation. If you can do the equation, it'll be really easy. Then over on page 9, there's some more practice for you to try, another table for you to fill in, and some more questions for you to answer. Do your best. If you have trouble with this, bring your questions to class or ask an adult for help. Good luck, and we'll see you in math.